In example 3, identify the scale factor of the dilation that maps ABCD onto A prime, B prime, C prime, as well as the center of dilation. Let's tackle the center of dilation first. So as we saw from some previous examples, that center dilation is the point that we're dilating all of our shapes away from, and that if we extend our center dilation to each of our corresponding points, then the image and the pre-image exactly line up on those same rays. Well, notice that we kind of already have that done for us. Come back over here so I can write on the screen. Way down here, are you dizzy yet? There we go. So, for example, if I were to connect, let's say, with a line B to B prime, and then D to D prime, you can see that they intersect at point A, and notice that point A and A prime are shared. That must be the center of dilation. So the center of dilation here, center of dilation is point A. All right, and now we want the scale factor. So the scale factor is supposed to be the ratio of side lengths. If I had coordinates, I could compare some coordinates or something like that, but the easiest way to do this is just to compare two side lengths. So let's say, for example, I pick BC and B prime C prime. I can divide those two different ways. It's either 6 divided by 2 or it's 2 divided by 6. I got to decide which one is it supposed to be. Well, when we're talking about scale factor, always remember it is new over old, right? If you think of it like that, it's pretty easy to see which one of these is supposed to go on top. Another way to do it, in order to be able to see which one goes on top, is to answer this question down here. Is this an enlargement or is it a reduction? Is your shape getting bigger or is it getting smaller? Well, since the prime marks are on the smaller shape, it must be a reduction. If it's a reduction, then that means that my scale factor needs to be closer to 0. And so that's also going to be an indication of how I can divide my numbers. All right, so which one is it going to be? Is it going to be 6 divided by 2, or is it going to be 2 divided by 6? In this case, it should be 2 divided by 6, which reduces to 1/3. The new side is the 2 side with the prime marks, and the 6 side is the original side. So, in other words, all of these side lengths must be as a 1/3 the size of the original ones. All right, I know what you're thinking. Look at the 4 and the 8. What about those two things? There's no way that this 4 is 1/3 of this 8. And you're exactly right. It's half as big. And the reason why it doesn't seem like it's 1/3 is because the whole entire side length is not 8. The whole entire side length is 8 plus 4 is 12. And now if I divide those things, I get 4 divided by 12, and I still get my 1/3 for my scale factor. So it still works out. Okay, for the next example, example 4, you need the handout that I suggested that you printed out at the very beginning of this. Otherwise, just, a graph grid. Just because the handout has part of this already graphed for us. So a graph shows triangle PQR with vertices at P, Q, and R. I'm not going to read them. It's already marked for us. And segment ST with endpoints at S and T, also given to us in coordinates. At what coordinate would vertex U be placed to create triangle SUT, which is a dilation of triangle PQR? All right, so let's take a look at that handout, shall we? And I have this just scroll down right. Nope, right there. There it is. All right, and then I can zoom in a little bit. All right, so we've got our original triangle right here, this PQR. Look at me coloring in the lines perfectly. All right, and if that thing bothers you, I'll get rid of it for you. Okay, so everybody's satisfied. I basically want to dilate this figure. I have no idea what the scale factor is. I have no idea what the center of dilation is. So I need to try to figure those two things out, okay? The way that I figure it out is by making my light rays. I'm going to connect to two corresponding points. And I know which ones correspond like this. S is supposed to correspond to P. So draw yourself a line that connects those two things. So for example, I'm going to start here at S. I'm going to connect it to P. Wait for it to straighten out, and then I'm going to keep going. Oh, it looks like very handily it goes through the origin. Let's verify that. Let's try this with T. Start with T and go to R. Wait for it to straighten out and then keep going. And it looks like it hits there as well. Bam. All right, now I need to keep going though. So the light rays are supposed to extend past those two things. So since I know origin is the center of dilation, I'm going to get rid of these and actually draw it straight from the origin. That's my little light rays here. Go through point S, make sure that it straightens out, and then just keep going there. All right, that looks like it's nice and lined up. And now do the same thing from the origin to T for it to straighten out. All right, that looks good. And now I want to do that one more time from the origin to our third and final point to Q, and then keep going. All right, there we go. All right, I did that because our missing point has to be on this new ray that I just drew in there, right? Our new point, whatever it turns out to be, it's got to be on that. Since we found our center of dilation of being the origin, that is really handy. So center of dilation. And the reason why it's handy is because if I could figure out what the scale factor is, all I have to do is multiply that scale factor times the coordinates of point Q, and I'd be in business. I'd be able to figure out where the corresponding point is supposed to be. So in order to do that, let's take our two corresponding points again, that's the S and the P, and see how we can get one of them from the other one. So our original point is P. It has the coordinate, let's see, 2, 4, it looks like. And it gets mapped to point S, and point S has coordinates 5, 10. Okay, so as far as the scale factor is concerned, I would be taking 2, my original coordinate, and multiplying it times some sort of scale factor, and I should get my new coordinate of 5. Pretty easy equation to solve. If I divide by 2, I get a scale factor of 2.5. In other words, all of our coordinates should be 2.5 times as big. Let's verify that with like 4. Is 4 times 2.5 equal to 10? Well, 4 times 2 would be 8, and half of 4 is 2. 2 more than that is definitely 10, so it definitely checks out. So then, what I want to do is find the coordinates of point Q and also multiply it by 2.5. So Q is at 8, 6. So what is 8 times 2.5? 8 times 2 would be 16, plus half of that would be 4. 16, 4 is 20. So S should be at, not S, what point is it? I think it's U. Is at 20, comma. And then do the same thing with 6. So 6 times 2.5. 2 would be 12, and 3 more would be 15. 20, 15. Let's graph it. Let's see if that makes sense. So 20, looks like it might be there. Let's see. Let's follow it up. Oh, it definitely is. Bam. So there's our point U. Connect that back to our points S and point T. And we have just dilated this by the scale factor of 2.5. Now go ahead and take 25 minutes to accurately color this in. Please do not color outside of the lines. You can see how perfectly I'm doing this, right? You should be doing the same. All right, so I think that's going to wrap up this particular video. I'm going to do a couple of more exercises involving dilations on the coordinate plane in the final video for this lesson.